Yeah. So, thank you very much for attending. That's it. Good morning, Your Highness. So hopefully, basically, you'll enjoy this presentation. So the presentation that I put together for you, basically, we're going to be exploring not just the technologies, but we're also going to be exploring the use cases and the future of a variety of different things. So, for example, blockchain, crypto, NFTs, and of course, the Metaverse. Now, I'd like to start here, if I can, with this particular video. Now, you might be wondering, in fact, you're probably wondering why I just played you that video. Now, when we start talking about the future, it's very easy to talk about individual technologies, but really what we should be doing is talking about how those technologies can be combined to create new products and services. Now, the video that I just showed you was a piece of immersive art that was created by an artificial intelligence. The soundtrack was created by a piece of artificial intelligence. I could sell it to you as a non-fungible token, which we will talk about, so as an NFT. In addition to that, once I owned that piece of artwork, and that was made by Bulgari as part of the LVMH group, I could sell you fractional ownership in that artwork. So for example, I could sell 1,000 fractional shares, which are like real shares, but NFT based or token based. And if I took that particular piece of artwork on tour, maybe I put it into the Louvre, when people came to see it, the people who have a fractional ownership in that piece of artwork would automatically get a dividend. So a little while ago, I was talking basically with the Minister for Higher Education and Advanced Skills basically for the Emirates. And we were talking about the use of artificial intelligence to create art, and then inevitably what happens when you create the AI, or when you kill the AI rather, that created the artwork. Does the price go up or down? So increasingly, we kind of live in this rather strange world. And as I travel the world, a lot of ministers, governments, and particularly older generations look at those kind of digital assets. And as Christine Lagarde recently said, they have no value. So, when we have a look at assets that are bought in gaming environments by our children, a lot of older adults will say they have no intrinsic value. However, as we'll see, value is in the eye of the beholder. And just because one generation doesn't necessarily understand this world or see value basically in, for example, digital assets, that doesn't mean that the generations that are coming up don't see value. So when we start having a look at all of the different technologies that we have coming down the line, I track over 450 exponential technologies. This is my technology starburst. There are 13 major categories. Every single technology on this particular starburst represents an addressable market opportunity of about $500 billion. And every single dot can either change one industry or every industry and every part of global culture and society, as well as business. So, for example, we have things that we aren't going to be talking about today, but 3D printing changes the $10 trillion manufacturing industry. When we look at artificial intelligence will be crucial in helping underpin some of the technologies that we're going to be talking about today. But we've already managed to 3D print artificial intelligence and create artificial intelligences out of DNA. let alone the binary and quantum artificial intelligences that we have coming through. Communications, we have 5G, we have 6G coming through in about 2028. When we have a look at some of the things that we're going to be talking to you about today, 5G supercharges a lot of the use cases behind some of these technologies and innovations. We have new compute paradigms, quantum computing, biological computing, DNA computing, liquid computing, and we sort of go around this wheel. We have neural interfaces, for example, as well as virtual reality and other immersive worlds. So when we look at neural interfaces, we already have the technology today to stream the images in your mind directly to YouTube. So the reason why I sort of show this is because often the world that you think that you live in isn't the world that we actually live in. Now, it also highlights the point that we already live in a world full of science fiction technologies, where those science fiction technologies are indeed science fact. So technology is this rocket ship. It is developing at an exponential speed. When we have a look at businesses, we have fast followers who try to keep up with the pace of technology development. And then we have regulators, basically, who are often far behind the curve, in some cases decades behind the bow wave of what technology is letting us actually do and achieve. For example, synthetic content and deepfakes basically is a very good example of that. Now, talking specifically basically about some of the technologies I mentioned, first of all, we have blockchain. So blockchain lets us decentralize everything. And I will talk to you about this in a little bit more detail in a moment. This is a fundamental principle of blockchain. It eliminates the need for intermediaries in transactions. It is also what we call a general purpose technology. So a general purpose technology is a technology that has utility and that can be applied to every single industry. It's also a technology that can be innovated on top of. So in blockchain's case, when we talk about future use cases as well as current use cases, there are literally millions. So blockchain is also a slow burn megatrend. Now, recently I was with a couple of governments in Europe and they say, well, we saw blockchain going through this period and now we don't really a period of hype, and now we don't really hear too much about blockchain. Blockchain is such a fundamentally disruptive technology that the only thing that it's doing is disrupting everything. As a consequence, it's a slow burn megatrend because it will take us a long time to embed blockchain and blockchain technology into all of the different systems and things that we are creating today. So for example, moving the web from what we call Web 2.0, which is what we see today, to Web 3.0 is a huge undertaking. It will take a lot of money, a lot of development and resources, and it will take a lot of time. So these are slow burn megatrends. Now, you might ask, what is a blockchain? So put simply, a blockchain is a chain of blocks that contains data, and it is a distributed digital ledger. So if you and I conducted a transaction in the past, or today, we might traditionally have had a bank that would record that transaction, the details of that transaction in their own ledger. And that would be held, for example, at First Abu Dhabi Bank. Today, however, that ledger, that record, is distributed among millions of different computers. Hence the term decentralized. So in terms of how blockchain actually works, you can kind of think of it in these terms. So firstly, a new block is created. So a new block that we store data in is created. It has a unique ID, which cannot be copied. And then we store data in that block. You can think of it as like a cardboard box that we put data in, and that cardboard box has a unique identification number. Now, then a peer-to-peer network validates the data within that block. And then if that data is validated, given a thumbs up, that block is added to the blockchain. And then we continue that process. Now, each block knows the previous block's unique identity number. Now, this is important because this means that the blockchain is an immutable way to store information that is very difficult to hack. It's not impossible to hack a blockchain network. You'd need to do something called a 51% attack, where you take over 51% of the computing power of a blockchain-based network, and then you rewrite all the blocks. We have seen a couple of those examples in the past, but it's very, very difficult to do. But nevertheless, you can do it, so that is something to sort of be aware of. Now, in terms of the benefits of blockchain, and this is why it's such a disruptive technology, there are lots. So firstly, it is efficient and fast. So if you think, for example, of the traditional transaction systems that we might see with DP World, for example, or Port Khalifa, basically with Abu Dhabi ports. Traditionally, when something comes into Port Khalifa, you might write something down in a ledger. With the blockchain, things happen and things are recorded in real time. So that's what we talk by efficient and fast. It has instant traceability. So once I've recorded data to the blockchain, anyone that is connected to that blockchain, anyone that has the right permissions, can see what data has been recorded. So this is important for supply chains, for example, which we'll come to. There is no central intermediary. Now, what this means is that you and I can conduct a transaction without the need for a middleman, whoever or whatever that middleman or middle person is. It's secure and it's encrypted. And a lot of people worry about quantum computers because by about 2025, it's estimated quantum computers will be able to break up to 70% of all the world's encryption, including things like SHA encryption, which applies to the blockchain, but that's a bit of a different conversation. So for now, blockchain is secure and encrypted. It's also transparent because, as I say, anyone who has access to the particular blockchain that we're interested in can query it, look at it, dig into it, analyze it, and sort of understand what's been going on. But at a very high level, though, while these all sound great, blockchain enables trust between third parties. So I might not know you, you might not know me, so fundamentally there's no trust between us because we've never done business together. Blockchain enables that trust, and it's trust that is the most powerful thing that blockchain gives to us all. Now, the last thing I mentioned on blockchain from a technology perspective is smart contracts. So this plays into the efficiency play. Once a set of criteria have been met, a smart contract is a program that runs on the blockchain that when predetermined criteria have been met, it executes agreements. So for example, if I ordered something from you and you sent it to me, as soon as I sign for that particular item, digitally, that now kicks off a smart contract because the smart contract says Matthew has received the goods that you've sent him and money automatically leaves my accounts. So this is another reason why blockchains are particularly efficient, because you can see there are lots of applications of this. Now, from a use case perspective, as I said, there are millions and millions of use cases. I picked some of the sort of more interesting ones and sort of more sector-specific ones. Now, we'll go into crypto in more detail in a little bit. But one of the main applications basically of blockchain, certainly from the very beginning with cryptocurrencies like Bitcoin and so on and so forth, is cryptocurrency. So the vast majority of cryptocurrencies are underpinned and built on the blockchain. We also have the concept of central bank digital currencies, which we'll come to. Now, with cryptos, they enable financial inclusion. They have a low transaction cost. So if you think about Western Union would charge me money to send you money. But with blockchain, I can send you money with almost no transaction fees. And in fact, depending on who I use, no transaction fees. And you get the money instantly, not in a couple of days' time. So no intermediaries. This is where cryptocurrencies, which we'll talk about, basically bring in the concept of programmable money, which is fundamentally disruptive in itself. We have real-time economic analysis, which I'll talk about in a bit. And then, of course, transactions are secure. We also have what we call DAOs, decentralized autonomous organizations. Now, these are new kinds of organizations that have no hierarchy. So there are lots of interesting use cases for these emerging already, but fundamentally we all own digital shares basically of a company via tokens. And I have voting rights, you have voting rights, and collectively we can decide what policies to enact and what policies not to enact. Now, when we actually have a look at the future of work, for example, one of the things that a lot of people typically leave out while we're talking about the future of work, of being able to work from anywhere, teleoperations and so on and so forth, is the way that we build companies is fundamentally changing as well. And I have a couple of examples of these. Now, with decentralized autonomous organizations, they're also... Oh, okay. It seems to be working okay my side.
No, I think it's working now.
Is it? Excellent. There you go. Thank you. That's it. Technology. It's wonderful. So decentralized, is that okay? There you go. Excellent. Thank you. So decentralized autonomous organizations also provide us with a possible route to helping solve some of the world's wealth inequality. It's not a silver bullet, but it does provide a bit of an answer. Now, this is sort of when we actually have a look at some of these decentralized organizations, we can have company as a protocol. So for example, Elon Musk, who's going through the process of buying Twitter, Jack Dorsey created a consortium called the Sky Blue Consortium, because Jack Dorsey thinks that the best future for Twitter is to turn Twitter into a protocol. You can also apply the same concept to government, where we have government as a protocol. So this is a fundamentally different kind of governance to anything that we've seen before. In addition to that, we've also seen the emergence of fully autonomous organizations built on the blockchain, using certain automation technologies like robotic process automation, artificial intelligence, and so on and so forth. And when we have a look at these fully autonomous organizations, there are now about 15. They're particularly prevalent in Hong Kong and Wall Street. These are organizations that do everything that a traditional organization does, just without any human involvement. So again, when we talk about the future of work and how blockchain can enable new ways of working, but also new styles of company and company ownership, these are quite powerful. We have healthcare. So in the healthcare space, blockchain will let one healthcare provider seamlessly share your healthcare data with another healthcare provider, which is particularly useful depending on the type of healthcare system that you have. If you have a look at the United States, it's quite a fractured and siloed healthcare system. Blockchain has a very valuable role to play there. Again, when we have a look at government in more detail, we have a full audit trail of everything that the government has done. All the policies that have been enacted, the results of those policies, and the analysis of those policies. And again, blockchain enables the secure third-party sharing of data between different government bodies and entities, which then means that we can bring all of the different government services together, which then means we can provide new services in new ways to our citizens, where all of those government services are joined up. So a little bit like the government blockchains that we actually see in Dubai. From a logistics perspective, we have the faster movement of goods because I get products coming into Khalifa Port. Once those products have been digitally signed in, that's automatically recorded on the blockchain. So this is where, from a logistics perspective, blockchains speed up imports and exports, as well as regulatory paperwork and all that kind of stuff. It also significantly helps logistics companies reduce their overheads and their costs. Robo-regulators. Now, in Japan and also in the UK, and then globally, the vast majority of countries, as well as startups and communities, believe that regulators are way behind the regulatory curve, particularly when it comes to regulating new emerging technologies, because those technologies let us do fundamentally new things in new ways that the regulators don't necessarily understand, can't get their heads around, don't have people who they can talk to about the associated upsides and downsides and risks. So in Japan and in the UK, the Financial Services Authority are now trying to create what's known as a robo-regulator. So this is where we use blockchain technology. So we call it a rail in this case. We digitize the regulation rule books so that it is machine readable by machine learning and AI. We connect different organizations like banks and fintechs, for example, to that rail. And when they do a transaction, on the one hand, basically they have access to global banking in 5 minutes with 5 lines of code. But if they go to undertake a transaction, maybe they want to do a transaction with Iran, the artificial intelligence checks that transaction, checks it against the digitized rulebook, and then says yes, no. So the automation of regulation and the ability to quickly update regulations, or quicker than we have been able to in the past, I think is a very interesting use of blockchain technology. It also provides real-time analysis and compliance basically for the regulators. They can see who's doing what, why, when, how, with who. Sovereign identity. So I was talking about this yesterday in Sweden. So again, when we actually have a look at the future, particularly from a privacy perspective, the ability for multinationals as well as other third parties to capture huge volumes of online and offline data about ourselves. So for example, just using this camera and artificial intelligence, you could automatically record my health data. You could tell me what my heart rate is, my blood pressure is, and everything else, and you could store that. So when we talk about the future of privacy, offline privacy that we've traditionally thought of as being private when we're offline is increasingly less so. So when we talk about sovereign identities, sovereign ID systems are blockchain-based privacy systems that let us control our own data. So I can see who's doing what with my data, who has access to it, how it's been shared. And using a sovereign ID system, we see these from companies like Accenture, Microsoft, IBM, and so on and so forth, even the United Nations. I can go onto the blockchain platform and decide that I want to rescind access to my data to Meta. So I say I just don't want them to have access to my data for whatever reason, and I can untick the box. They no longer have access. So sovereign ID systems are very interesting, but very few organizations and governments are actually rolling them out at all because a lot of our data is collected by big multinationals based in other countries. Supply chain transparency. Companies like Walmart are using the blockchain. So it used to be the case that if they had infected pork coming in from China, they would have to clear all of the shelves. And that was a big problem because they didn't know what particular batches of that product had been infected or needed to be recalled. So with supply chain transparency, they can now tell instantly which specific packets, for example, need to be recalled. But again, you can record all of the data of that food or that product's provenance from the time that it was created to the time that it was destroyed on the blockchain. So you scan a QR code on a piece of food, you can see where it was grown. Maybe it was grown in a vertical farm in Masdar. You can see the conditions it was grown in. You can see how it was transported, the temperature it was transported at, and so on and so forth. So supply chains basically are set to benefit greatly from blockchain. So that's the blockchain piece. Now, when we have a look at cryptocurrencies, cryptocurrencies are widely regarded as the most convenient form of money ever. They let us do some really interesting things in new ways. Now, what is a cryptocurrency? So when we have a look at cryptocurrencies, there are about 6,000 of them today, and there are many more coming down the line. They are a 100% digital asset. They allow peer-to-peer transactions. So based on the blockchain, I can send you money, you can send me money without that intermediary. So they're decentralized again. So cryptocurrencies have a lot in common with the blockchain because they are based generally, not always, but generally on the blockchain. They are a digital medium of exchange. They are secured by cryptography, hence the name. And then those transactions of me sending you money or you sending me money are stored on the blockchain. So this is why I said blockchain is a general purpose technology, because it enables all these other things. Now, with cryptocurrencies are increasingly a programmable form of money. And I'll explain what that means. So because cryptocurrencies are digital, they are thereby programmable, which means that we can do a couple of interesting things. Now, if you have a look at the Chinese digital yuan, the ECYN, you can actually, as a government, give money an expiration date. Now, this is actually useful for a variety of different reasons. Now, so particularly when it comes to things like central bank digital currencies. So a central bank digital currency is a digital form of a country's real currency, the fiat currency, so like the dirham. That's all it is. However, one of the biggest advantages of central bank digital currencies is firstly, well, you have real-time economic analysis. So for example, if you're in Abu Dhabi and you see that no one is visiting the Louvre, as the local government, you could send out a text message to people saying, if you visit the Louvre today, we will give you 10 dirham, or you won't have to pay tax, or whatever it happens to be. So because central bank digital currencies, in their case, are based on distributed ledgers, so it's a sort of cousin of blockchains, this means that you can, in real time, see exactly what is going on in different parts of the UAE from an economy perspective. Now, as such, because we have programmable money, what you could do is you could artificially stimulate different parts of your economy. So for example, if people are in Dubai Mall, but you see that they aren't buying products from particular retailers, you could again send out a 10 dirham bonus saying, we're going to give you 10 dirhams to spend at the Dubai Mall. And if you don't spend it, by the end of the day, it's expired. So this is where, when we start having a look at the future of country-based economics, cryptocurrencies and blockchain become very interesting and let us do some interesting things in interesting ways. Now, when we have a look at cryptocurrencies themselves, these are sort of more the private style cryptocurrencies like Bitcoin, Dogecoin, etc., etc., etc. They have no fundamental value. So Bitcoin, for example, is not tied to any value store. It's not tied to gold or a commodity or to fiat currencies, which means that the value that we see in cryptocurrencies, traditional sort of private cryptocurrencies that haven't been created by governments, are very risky. As we see, they go up and down. We just lost $300 billion basically, just got wiped off the crypto markets the other day. But the value of those cryptocurrencies is based on the value that you and I see in them. That's it. So it's kind of that perception is reality. But they are, in that way, a sense of a a store of value, and they are a unit of exchange, because I can trade my cryptocurrency with you, and you can get goods or products and services along with that. But traditional cryptocurrencies, like Bitcoin and everything else, they're risky, they're volatile, and as a consequence, this is why a lot of organizations are now looking at stable coins. So stable coins basically are pegged to a commodity, a currency. It can be a real currency, so like a fiat currency, cash. It can be pegged to a cryptocurrency. So stable coins could ironically be pegged to Bitcoin using algorithms and all that sort of stuff. Or they can be pegged to financial instruments and other commodities. So we can peg them to gold, or we could peg them to ETFs or other kinds of things. But the idea with a stable coin is it is pegged to something that has tangible value. Now, the idea behind that is in the name, because once a stable coin is pegged to, for example, the US dollar, you're not going to see these wild price swings that we see with Bitcoin and other cryptocurrencies. It's going to be more stable, which then means that as a unit of exchange, stable coins are a lot more, shall we say, trustworthy. Dangerous word. I'll show you why in a moment. They are slightly less risky, but not risk-free. So this is where stable coins increasingly are being used by governments like the Australian government to try to iron out some of the problems that we see with traditional cryptocurrencies. And then there's Terra. So you might have read about this recently. Terra USD was a stable coin based out of South Korea. And this is where we go into very strange new concepts with these stable coins and cryptocurrencies. So the idea behind Terra is Terra was pegged to the US dollar. So 1 Terra coin was worth $1, roughly. About a week and a half ago, as Terra started crashing, the owners of Terra depegged it from the US dollar. In other words, it was no longer connected to the US dollar. Suddenly it was floating free. So this has shaken a lot of people's faith in stable coins, because today I peg my cryptocurrency to the dollar. Tomorrow, I don't. That's a risk, and it's also a regulatory point. Now, in addition to that, as Terra kept crashing, the owners of the network just turned the network off. Now, if you had money in Terra, that's your money gone. You can't do that with a traditional currency. You can't turn off cash. You shouldn't be able to do it with a central bank digital currency. But we are now living in a time where I can just turn your money off. It's gone, and it's not coming back. But in addition to that, because Terra's overall value was based within the community, we saw over 50 billion Terra coins burned by its users. So users were saying the value of our coins is down here. So in order to increase the value of Terra, we want to limit and reduce the supply of Terra coins in the market. So Terra literally allowed people to send billions, tens of billions of Terra coins to what we call a burn wallet. So imagine doing that with a traditional currency. Imagine just doing that with dirham, where you go, there's too many dirhams basically in the marketplace. As a consumer walking around Dubai Mall, I'm just going to burn my dirhams. So this is where a lot of these new technologies enable some really good new things, but they also enable some really odd new things that the regulators need to get their arms around. Now, in terms of making cryptocurrency, this is sort of an interesting one, because I thought I'd sort of put this in because it actually has applicability. So when we have a look at the future of transportation, cars are essentially giant computers on wheels. They have GPUs in them. So when a car becomes autonomous and drives around Dubai or up the Sheikh Zayed Road, increasingly, there are organizations like DayMac over in the US that enable that self-driving car to mine its own cryptocurrency. So what would happen if, as a government, you had fully autonomous RTA taxis going up and down the Sheikh Zayed Road, and they were making you cryptocurrency that you could then use to fund investment, basically, in the Emirates? In addition to that, your city can mine cryptocurrency. Now, this is one way to eliminate all taxes on citizens within any country. And it works like this. So in Miami teamed with an organization called Citicoin. Citicoin is a kind of cryptocurrency. And this is called the MIA coin, M-I-A coin. In Miami, they have about 500,000 people. And the city of Miami lets all those people mine cryptocurrency. Now, as a citizen of Miami, mine cryptocurrency, I get 70% of the yield, the profit, the dividend. The city gets 30% of the profit. In Miami's case, they have already earned over $100 million doing this. And the city's mayor has said this: when they reach $400 million, he will be able to go to the people of Miami and say, I'm eliminating all taxes on you. And when they say, but what about investment in infrastructure, schools, events, education, all that sort of stuff, they will still have the money to do so. So this is a fundamentally new way to raise capital without the banks. It's also a fundamentally new way to fund infrastructure. But there are risks. However, it's a very interesting one. And then, just as a piece of oddity, Microsoft have now put forward a patent which has been accepted by the US Patent Office to let people mine cryptocurrency with their mind. Now, when you start thinking about some of these things, we talked about cryptocurrencies being one of the most flexible kinds of money. It's also the oddest. So I'm showing you these because this is the stuff that's coming down the line, and this is the stuff that's already here. We couldn't have traditionally done this with traditional money. In addition to that, with cryptocurrencies, we have this concept of do something to earn money. Now, this is where we have create to earn, learn to earn, play to earn, use to earn, and volunteer to earn. Now, when combined with other mega trends like Internet of Things, for example, as a government, you could do this. So if I have a smartwatch, you could push out an alert via my smartphone saying, if you walk up the Burj Khalifa, as opposed to taking the elevator, which is the better way to go up the Burj Khalifa, admittedly, we will pay you some money, some cryptocurrency. So doing that with traditional money would be very, very difficult. So this is where you can think of new things. So for example, volunteer. If you volunteer to clean up the beaches around the Burj Al Arab, we've got cameras, we know it's you, we can use facial recognition and everything else. For every piece of litter that you pick up, we will give you 1/1,000,000th of a crypto coin. So this is where we start unlocking a lot of new possibilities and new potential. When we have a look at NFTs, so NFTs are sort of fairly straightforward. So NFTs are non-fungible tokens. They are always digital. They can be anything as long as it's digital. The ownership of an NFT, which is like a token, in fact it is a token, is stored on the blockchain, and they are unique. So a non-fungible token is something that is digital, its ownership is recorded on the blockchain, and it's unique. That's pretty much it. Now, this is also why we need custodians. So this is where we get into digital assets and all that sort of stuff. So if you take a photo of the screen in front of you, you can go to a platform like OpenSea and you can turn it into an NFT. And then just like we see with regular artwork and other digital assets, You can make up a story about that particular picture. You know, this is an amazing picture of something, you know, whatever it happens to be. And then people will either see the value in that or not. So for example, again, this brings us to when we talk about the value of digital assets. I remember going to the Tate Gallery in London, and there was a picture on the wall, and it was a blue square in a blue square. And it was priced at $2.5 million. And my children could have painted a painting with a blue square and a blue square. But with a lot of digital assets, it's the story, just like traditional artwork, it's the story that counts. This is why we find value in something that fundamentally might not actually have any value whatsoever. So as we start moving into things like Web 3.0 and so on and so forth, the being able to record digital assets in a regulated and authorized way is very important, because if you own an NFT on a platform like OpenSea, what happens if OpenSea goes bust? What happens if OpenSea turn their network off? I've spent money with them. What happens to my stuff? So this is where we have this new economy, and this is sort of where VARA obviously sort of starts having a play. Now, from use case perspective, you can use NFTs to buy anything digital. So it can be art and music. So I can buy a digital GIF. I can buy Jack Dorsey's first tweet, etc., etc., etc. I could buy access and membership. So for example, you could have a Dubai NFT. So when I book my flight on Emirates, I get the option perhaps, because Emirates are experimenting with NFTs, to buy a Dubai NFT. And that Dubai NFT grants me free access to the Museum of the Future, which is very nice, by the way. But it also might grant me other access to other things, whether it's real services, digital services, real places, metaverse-based places, and so on and so forth. So we can do all kinds of things. Now, while many people think that NFTs only let us buy digital things, that's not the case. Because increasingly, entrepreneurs being entrepreneurs, I can buy a digital picture of a house like this one. And this is a real thing, by the way. And if I buy the digital picture of the house, I get the real house. So this was actually done in the United States. And the regulators in this particular case say, we have no idea how to regulate this. We don't know if you buy a picture of a house that comes with a free house. We don't know how to manage that asset or the title to that asset, etc., etc. So increasingly, we will see organizations, including like Adidas, where you buy an NFT of, say, the Bored Yacht Ape Club, because Adidas have just teamed up with them. And when you buy an Adidas NFT, you get a pair of sneakers. So you just go and walk into the Adidas store, show them your code, and they'll pick a pair of sneakers off the shelf and say, there you go. So while NFTs basically have originally been designed to let us buy digital assets, companies are increasingly starting to combine digital assets with real-world assets, which brings us to a term called FI digital, physical and digital products. You can also raise a pet as an NFT. So this is an interesting one because while we talk about decentralized finance, for example, in the financial services community, we have this concept increasingly of game finance, GameFi. It's a play on the DeFi, the decentralized finance trend. Now, there are actually games that will let you raise a pet, like Roblox and Fortnite and all these others. So as you're raising your pet in a game, and as that pet is getting bigger, that pet becomes an NFT. It's your NFT. So my kids could go into a platform like Roblox, raise a pet cat, and then they could sell that pet cat on the OpenSea marketplace or other third-party NFT marketplaces as an NFT that someone else can buy, and then that pet cat in that virtual world is then owned by somebody else. But my kids, who are always playing computer games and everything else, this could replace their pocket money, aside from anything else. And then finally, basically the sort of last topic of the day, the Metaverse. So the Metaverse starts bringing a lot of these different technologies and things together, because actually you can bundle all of these into the Metaverse in different ways. Now, it shouldn't be lost on you that while we're talking about the Metaverse, if you go to the Merriam-Webster dictionary, the Metaverse has no definition. So everybody all around the world is talking about the Metaverse, this thing that actually has no formal definition in any dictionary anywhere. So we're very early stage. But it also shows again basically how technology moves faster than a lot of the other societal constructs, like dictionaries and regulators and all sorts of stuff. So I kind of define the Metaverse like this. The Metaverse is three worlds colliding. It is the digital world, the physical world, and the virtual world colliding. Now, I know that a lot of people say that the Metaverse is the physical and digital world colliding, coming together, but it's not. Because digital is something like Netflix. Digital is e-commerce. Digital is something different. If you digitize the government, digitize your company, you haven't just put it into a virtual reality world. You're using robotic process automation or whatever you're up to. So this is why I make the distinction. You've got the merging of the digital, physical, and virtual worlds. Now, this has some very serious and very big consequences, upsides particularly. Now, this means that when you are creating new products or services, doesn't matter whether you're a government, whether you're a country, whether you are a multinational organization, you should really be asking yourselves three questions. So firstly, if you create a physical product, what is it? Why is it? What's its utility? But with that physical product, how can I digitize it? Maybe you turn it into a smart product. So this is where we use digital technologies either within that physical product or to surround that physical product with. And then how can we virtualize it? And why? So for example, a traditional t-shirt. So an example of a traditional t-shirt, like an Adidas t-shirt, is I create a physical version of the t-shirt. I digitize the t-shirt by turning it into a smart t-shirt, maybe, that I sell on an e-commerce site. But then thirdly, I create a virtual replica of that t-shirt, and as Adidas, sell that maybe as an NFT in Roblox, so now people in Roblox can wear an Adidas t-shirt. So this is why when we look at how we build new products and services, you should be looking at increasingly in this world, how can we leverage it physically, digitally, and virtually. This also brings us on to a new global economy reality, because increasingly we have the physical economy. So for example, in the UAE, the physical economy is maybe I, as a tourist, come to Dubai. I'm there physically. We have a digital economy. So as Dubai and Abu Dhabi, you sell digital services. That is perhaps e-commerce, over-the-top entertainment, and so on and so forth. So OTT. But then also virtual economy. So I can visit the Louvre in virtual reality. So from an economic perspective, we kind of get into this area of what we call multi-dimensional economies. We have a physical UAE economy, a digital UAE economy, a virtual UAE economy. But then in addition to that, these merge. So these can actually be connected to one another. From an investment perspective, it's a fundamentally different kind of investment future, an investment vehicle that we can put together. And of course, Metaverse, or the Metaverse, basically is a slow burn megatrend, which means it's going to be hyped over the next 1 to 2 years. Everyone will talk about it. And then come 2024, not many people are going to be talking about it because we'll go through that trough of disillusionment. And then in 2027, 2028, suddenly it'll start coming back, like we saw with blockchain. Now, the Metaverse is not a single technology. So when we talk about when will everyone use the Metaverse, when will we be able to do particular things in the Metaverse, this is dependent on lots and lots of different technologies maturing. So for example, we have artificial intelligence, we have significant performance increases in compute, because increasingly the Metaverse will be streamed from the cloud, which is where investment in data centers is important. Haptics, so for example, if we were in the Metaverse now, using haptics, I could be wearing a haptic glove, we could high five each other, or shake each other's hand, depending what you prefer. Metamaterials. Now, most people don't pay attention to materials, but materials are really important because metamaterials will make the Metaverse come to life in new ways. It will make it invisible, and I'll show you that in a little bit. Got networks, so this is where 5G, we're streaming the Metaverse from the cloud. 5G is a core technology. Rendering engines, so because while we're streaming the Metaverse from the cloud, we increasingly want it to be photorealistic. Now, this is where we see significant improvements by seeing rendering engines and rendering technology from companies like Unreal and the Unity game engine. This is where the gaming industry is incredibly important for the future of the Metaverse for a whole bunch of different reasons. So we already have the ability to render virtual reality, because that's what the Metaverse really is, to render virtual reality worlds in ultra high definition. We've got sensing systems because, for example, with the Oculus Quest, I can get rid of the controllers. I can just replace it with a ring. So sensing systems sense what I'm doing, where I'm doing it, whether I like it, whether I'm smiling whenever I'm doing something in the Metaverse, and whether, and all sorts of other things. We also have this. So we're at Metaverse 1.0 at the moment. Metaverse 1.0 means that we can interact with virtual reality, aka the wider Metaverse, which is just a collection of smaller platforms, using my eyes and my hearing and maybe my sense of touch if I have some haptic gloves. So Metaverse 1 is fairly basic, but I go in and I can look at things and I can hear things. And maybe I can touch things as well. I can pick up a ball, I can throw it to you, you can throw it back, which is an interesting esports experiment. Now, when we talk about infinite worlds, you can obviously create any kind of world that you want within those virtual reality and metaverse environments. Today, it's humans that are creating these worlds. However, we have companies like Promethean AI where you talk to the artificial intelligence and say, build me a house that is 3 stories tall, made out of marble, and has flamingos walking around inside of it. And by combining different technologies together, like natural language processing, conversational artificial intelligence, etc., the artificial intelligence will create that world for you. So how we create metaverse experiences is changing. And then eventually, in about 2035, and we're already seeing this today, AIs will be able to create what we call procedural virtual reality environments, where the AI, without any human intervention, create the world for you. So as I'm walking around, if I look sad in the virtual reality world, that's where using sensing technologies, the creative artificial intelligence, that's their name, creative artificial intelligences, which is part of the synthetic content trend, will know that I'm actually a bit upset, and it might put a load of flamingos in my house, and so on and so forth. So increasingly, we have human-created content, hybrid created content, human and AI, and then AI, purely AI created content. Now, from a digital asset perspective, we still have this problem called the teleport problem. Companies like Ready Player Me are trying to break this down. And again, this is a sort of regulator play. So if I buy a digital product in Roblox, maybe it's a skin or a Gucci handbag, you can buy one of those, and I want to take that digital asset into another virtual world, then I can't generally today. So one of the problems that we have is when we have a look at Web 3.0, there are lots and lots of people creating Web 3.0, and they say in the future, things like the metaverse will be this open, decentralized, democratized space where anyone can do everything, where everything will just work with one another, and platforms basically won't have any power over us. You won't be able to control what we do. You won't be able to turn it all off. That's not right. And the reason that's not right is because you are either, as we sort of saw with the conversations we had last time, you are either building your virtual reality metaverse on a Microsoft platform, a Meta platform, an Epic platform. So platforms will still dominate. And even though these large multinationals will say that they want people to trade freely between them and that you can move freely between these different platforms, let's face it, they're all going to want you to stay on their platform for as long as possible to spend as much money as you can with them. Now, as I mentioned, metamaterials, when we start having a look at the future of the metaverse, basically this is where increasingly we'll be able to access it just with a pair of sunglasses. So metamaterials literally let us make sunglasses that are virtual reality sunglasses. So we can get rid of all of the gadgets and everything else that we actually have today. So if I want to go into the metaverse today, I put on some sunglasses. I've got my, what we call an EMG ring, which replaces the Oculus controllers. I'm in. So when technology becomes invisible and lets us step into new things and new experiences just by putting on a pair of sunglasses, that's when more people will actually start using the metaverse and virtual reality. The end game for the metaverse, though, really is to try to create a set of realities that are indistinguishable from the real thing. So we get to the point almost like the Matrix where we don't know if this is the real world or, as Elon Musk said, whether or not this is a simulation. And this kind of comes down to, what's real anyway? Reality is a perception. We think that the world that we live in is real because I can smell it, I can feel it, I can poke stuff and all that sort of stuff. But does that just set a set of chemical experiences in my brain, like the Matrix? Now, increasingly, basically, we have people all the way around the world, especially in Japan, that are creating new virtual ways to interact with the metaverse. So today we can do sight, sound, and touch. However, we can also do taste and smell. So you can taste virtual food in the metaverse, thanks to researchers in Japan. You can also smell virtual things in the metaverse, thanks again to researchers in Japan. So there's lots of sort of odd technologies coming through. As well, if I want to walk around the metaverse, we've got virtual reality boots, for example, as well as electromagnetic floors that would let me be standing still in a place like this, and I'd be walking around, and I'm walking around a Minecraft environment or the metaverse, because we're trying to solve the you have to stand still when you're in the metaverse problem. And then we've got neurotech. So companies like HTC have already designed virtual reality headsets that let you control and interact with virtual reality environments using nothing more than your mind. So again, from a regulator's perspective, how do you regulate that? Plus, from a privacy perspective, that opens all sorts of new doors and issues. But when we have a look at the metaverse, while a lot of people are saying the metaverse is really a digital twin of the real world, it's a lot more than that, because the metaverse doesn't have to obey natural laws. In fact, when we have a look at natural laws, you can create an upside-down world, basically in outer space, basically, that will enable you to dive off Mons Olympus, basically on Neptune. So this is sort of where younger generations especially will be attracted more and more to the metaverse, because you can just do extraordinary things, especially as it becomes more and more difficult to distinguish what's real from what's not real. Older generations, when they sort of look at this sort of thing, they go, But who would want to live in virtual reality? And yet we've created a virtual reality school. You can't get kids out of a virtual reality school, which is a good thing, let alone basically a virtual reality game environment that they increasingly think is real. So again, when we're having a look at the projection of a lot of these different technologies and use cases and everything else, you have to think not just about the technology, but also from a multi-generation perspective, because different generations have got a very, very different view of all these things that are happening today. And then when we have a look at digital humans are authentic looking, real looking humans. They are digital. They have neural network brains. This is Doug. And increasingly, we are going to see digital humans walking around and playing a part in the metaverse, which then sort of brings us into this. We have these from companies like Soul Machines, Samsung with Neom, and so on and so forth. But what happens when you are talking to someone that you think is real and it's actually an artificial intelligence bot or digital human? There are people that think that these will never become photorealistic or convincing enough to fool people. I can show you ones that can fool people today. So these digital humans are also competing against people in esports arenas as well, and they're trashing humans. So when we talk about potential future crime, future problems, and everything else in the metaverse, there's a whole lot of stuff coming. And then finally, if we look at use cases, so the metaverse is much more than next generation social media. It's also much more than just the real world's digital twin. And you can put every experience into the metaverse. So obviously along Metaverse 1 and Metaverse 2 lines today, sight and sound and touch. So for example, you could put the Louvre into the metaverse and I could be walking around the Louvre and I could even be touching the paintings that you wouldn't let me touch basically in the real world. But those paintings could also be turned into an NFT. So I could then interact with them. I could walk through them. I could do all kinds of different things basically with a metaverse-based Louvre that I simply couldn't do today, or that you'd arrest me for today, which is where we get into virtual tourism and all those sorts of things. But you can turn every experience into a metaverse-based experience. It's applicable to every sector. So for example, in the banking sector, JP Morgan created the first metaverse bank. Now, we estimate that the metaverse has a market opportunity of about $800 billion. When we have a look at Web 3.0, we estimate that the market opportunity for Web 3.0 is between $8 to $13 trillion. Now, in JP Morgan's case, they created a metaverse bank. And it actually was for three purposes. Everyone just thought it was just a funny experiment because it had a tiger running around it. So firstly, they experimented and tried to figure out, how do you create a bank in the metaverse? And why? What do people do with that? Secondly, it showed basically to the assembled audience and the people that JP Morgan were trying to hire, it's like, hey, it's an advert. Come to JP Morgan and work for us because we are doing interesting things at the leading edge of technology. So it makes JP Morgan an interesting company to work for. But thirdly, and this was really what they were up to, JP Morgan are positioning themselves to be the digital lender of choice so that when you buy your digital assets, like your digital NFT Mona Lisa, your digital Louvre experience, your digital real estate, you come to them for a digital NFT mortgage. And those exist, by the way. So we have education, as I say, so we've actually got schools now in the metaverse, which is fun. Entertainment, government. When we have a look at government, for example, South Korea basically is putting the government basically into the metaverse so that we go into the metaverse and you can access different government services without actually having to go to Seoul and so on and so forth. The gig economy. We've seen people like Travis Scott with Fortnite and Epic who have held mass events in the metaverse already. Now, in Travis Scott's case, for example, we had 12 million people actually go in. And from a marketplace perspective, all those people will be buying skins, virtual merchandise, and so on and so forth. So from Fortnite's perspective, Fortnite are starting to bring together NFTs, cryptocurrencies, tokens, as well as all these other things that we see. So these are becoming, hence me saying, look at, from an economy perspective, look at virtual economies as well, because this can mean you break beyond borders. We have public services. So for example, again, basically down in South Korea are now turning Seoul into the first Metaverse city. And I think Dubai basically is also doing very similar. And then of course we have virtual realty. So I can go into the Metaverse, I can buy virtual land in a virtual place that, as Christine Lagarde keeps saying, doesn't exist. But I still think there's value in that. So in some cases, people have paid millions of dollars for virtual real estate. And last year, people spent $500 million buying virtual real estate. And estimates put that at a $1 trillion market, which is a little bit insane. We also have virtual nations. So for example, could you put the whole of the UAE into the Metaverse? Now I can do a number of interesting things, which I can do anyway with solutions that we see from Estonia, for example. So we could have e-citizenship, e-residence. So if people come to work in a virtual Dubai, for example, because we have virtual offices and everything else, you could have a Dubai NFT that says, well, because you are a e-resident of Dubai working in our virtual world, we will give you access to whatever it happens to be. It could be healthcare, Dubai or UAE education, all kinds of different things. So this is sort of where we get into some interesting concepts about, what is a resident. Now, we also have benefits and taxes, and then we move, say, for example, the UAE from having physical borders to digitally having no borders whatsoever. So virtual nations, if you think about Facebook is essentially a virtual nation of 3.2 billion people. Because Mark Zuckerberg could all of a sudden say, today, everybody, education is free. Log into here. So virtual nations are a very real construct already, but the Metaverse could make them even more interesting. And then we have virtual workspaces. And I wrote a codex a little while ago, so it's a Trends and Technology Codex. And just for a laugh, basically, I wrote the majority of it in virtual reality. And it was interesting because I would be writing my book in virtual reality in outer space. It was an interesting play. But virtual workspaces, this is where we look at virtual landlords, as we see in Hong Kong and so on and so forth. And then that's it. So I hope you've enjoyed that. I hope there's a lot of food for thought in there. These are big areas, as you can gauge. But thank you for listening.